All right, folks, today we're doing properties of logarithms. We're going to use the four properties that we learned in class today: the change of base, the product, the quotient, and the power. Okay, so this first one, it's going to be log of 6 times 11. And we're going to go ahead and use that product rule, which is going to be, and to expand it, we're going to use a product rule. And the product rule says um, log of A times B, that's going to be the same as log of A plus log of B. So give me a second. There we go. So this one's going to be, and this, since there's no base with this, we're just going to go ahead and call it log or log base 10. But log simply is just fine. So this will be log 6 plus log 11. And that's all there is to it. Okay. Second one, same thing again. Same type of idea. This will be log base 10, but we won't write it down. So if you don't write it down, it automatically means base 10 of 5 plus log of 3. And they're both base 10. Okay, same thing. So this next one we put in a different color because it is a little slightly different. Okay, you can work this two ways. First way, you can use a power or the exponent rule for logarithms. You can bring it to the front like that. So this is going to make 5 times log 6 elevenths. And again, keep in mind this is 5 times. So if it's 5, the whole thing times 6 log 6 over 11, which really means 5 times, and then the inside log of 6 over 11, that is the quotient rule of log 6 minus log 11. And then with the 5 multiply into there, this comes out to be, well, actually, I will just put it on the side. So this will come out to be 5 log 6 minus 5 log 11. Okay. Now, similarly, we can do it this way as well. And I'll put it in orange just so that we know it's related. Okay. We can also apply that exponent to the argument of 6 over 11. So we can also have the answer of log 6 to the 5th over 11 to the 5th. So this is a second way of doing it, which will be equal to, and then we're going to go ahead and use the quotient rule, log 6 to the 5th minus log 11 to the 5th. Then we're going to go ahead and use the power rule, which means that these exponents can come to the front. So same thing like that. And as a result, we end up getting 5 times log 6 minus 5 times log 11. And you can see that they're both the same answer, whichever path, whichever route you take. Okay, many paths, one destination. Something Yoda would say. Master Yoda. Not just any normal Yoda, Master Yoda. Okay, same thing here. Notice that this is, first off, we're going to have a product. So I'm going to go ahead and use blue because that kind of matches what we did up there. So this would be log 3 plus log 2 to the third power. And because the second term has a power, we're going to go ahead and use the exponent rule. So this is going to be log base 10 of 3 plus, and this exponent is going to come to the front because that's what the exponent rule allows you to do. So this will end up being 3 times log 2. Okay. Number 5. This one's going to be, and notice it's a quotient rule. So this is going to be log 2 to the 4th power minus log of 5. And both of these are log base 10. Normally, I would write little 10 underneath there. Okay, but if you don't see a 10, or you don't see a base at all, then it automatically, means log base 10. Let me get that erased. Okay, so these both just mean log base 10. Right, and then the only thing going on is that there's an exponent or power rule on the first term, so this will end up being 4 times log 2 minus log 5. And if you want to show the times, you can put a little dot there to show times, but you don't really have to. I'll just leave it there. Okay, number 6, we've got, and again, it's the same idea. I'm going to go ahead and distribute that, not really distribute, but I'm going to go ahead and just say this 6 right here kind of distributes into the 6 and into the 5. All right, so that's not really a distributed property, but I'm going to go ahead and say it's going to distribute. So we'll rewrite it as log 6 to the 6th power over 5 to the 6th power. And then this is a quotient rule of log 6 to the 6th power minus log 5 to the 6th power. And then we're going to go ahead and use the power rule, and this is going to end up being 6 log of 6 minus 6 log of 5. And remember, that was using the power rule, which means that each of these exponents can be brought to the front of the log and be multiplied, which is what's happening here. Okay. 7, another quotient. So this is going to be log x minus log y to the 6th power. And notice that there is a 6th power, so we're going to use the exponent rule, and it's going to be brought to the front. So now we're going to have log x minus 6 times log y. Okay, same thing here. I'm going to use blue for this one because it's multiplication. Again, I'm going to go ahead and do a, I'm going to call it distributed property, and it works like that. But it's not really distributed property. It's just a times b to the 2nd power, which means that a gets a 2nd power and b gets a 2nd power. Right? So this is going to end up being log a 2nd power, b 2nd power. Right? Which now is going to be a product rule, and we're going to get log a 2nd power plus log b 2nd power. And then I'm going to go ahead and use the power rule and bring each of these exponents to the front to expand them. So we will have 2 times log a plus 2 times log b. Right, and if you want to further expand them, you can call each of these log a, because there's 2 of them. So you can really say a log a log a plus a log a. And then back here, there's 2 of the log b, so you can say plus a log b plus another log b. So this way, it's really, really expanded out. Okay, you don't have to go that far. That is just if you want to truly, fully expand this out. I'm going to go ahead and, because I need that space, I'm going to go ahead and erase that. And we're okay with just the exponent in the front. Okay. Okay, number 9. This is a quotient. So this is going to be log u to the 4th power minus log v. And then this is a power rule. So I'm going to go ahead and bring this 4th power to the front. And we're going to end up with 4 times log u minus log v. Okay, another quotient, log x minus log y to the fifth power. And again, since it's a quotient, or excuse me, since it's a power, you bring this to the front of that log. This will end up being log x minus 5 log y. And if you want, you can put a little times multiplication table or symbol over there. Okay, 11. A little tricky, but I think we got this. I'm going to go ahead and write this in black because what we're going to do is we're not going to do anything yet. So I'm just going to rewrite this. So log base 10. So I'm not going to write a 10. But cubic root of x times y times z is actually x times y times z. And the cubic root is also known as 1/3 power. That's right. So now we can do a little rewrite. We can call this log x to the 1/3 times y to the 1/3 times z to the 1/3. Okay, now this is a product rule. Okay, product rule says we can take the log of each of these product or factors of the product. So log of x to the 1/3 plus log y to the 1/3 plus log z to the 1/3. And each of these are powers, so we can bring into the front of the logs. You get the idea. We've been doing this for a couple problems already. So we will have 1/3 log x plus 1/3 log y plus 1/3 log z. Okay, that's the final answer. And you could have went another route on this, but I think this is the most straightforward. Other route you could have went is from um, from here. You can take this and you can bring this 1/3 to the front using the power rule first, and then that 1/3 is going to get distributed into the log of x, y, z using the product rule, which means log x plus log y plus the log z, and then that 1/3 is going to get multiplied into all of them. Okay, so you could have done any way, but I've chosen to go this way. Okay, same thing as the last one, except not as difficult. This is going to be log, and this one's actually pretty straightforward. X plus log y plus log z squared. And in this case, we only notice that only the last term has this power, which means we can bring it to the front. So our final answer, log x plus log y plus 2 times log z. Okay, if you need any of those answers again, you can rewind through this. Okay, next page, backside. Now this backside, we're going to condense it. Okay, so condensing requires you to notice or to know some of the properties or the rules for manipulation of logarithmic functions or expressions. So this is a subtraction, which means that when I'm done with this, I'm going to end up with a log and a quotient, which means division. Okay, and it's really just going to be 3 on top, 8 on the bottom. You can leave it like this, or you can put a parentheses. It's up to you. Okay, let's say the first one, I'm going to put a parentheses. Okay, now this next one, it's probably going to get a couple of you guys, but it's not 6 divided by 3 as part of the argument for a log. Okay, this is not equal to log 6 over 3. Okay, or else it would be written that way. This is actually, and I'm going to put it in black because I'm not doing any of the logs yet. This is actually going to be 1/3 times log of 6. And think about it, it's like this. It's log base 10 of 6 over 1 times 1/3, and that's how we get this answer. Okay, or not the answer, but that setup. So with this, get rid of my dots. Okay, I'm going to go ahead and utilize the power rule. The power rule says, I'm going to use green on that. And this is the backwards, or um, the other direction of how the power rule can go. You can take this product, and if it's being multiplied to a log, you can actually bring it in as a exponent. So the final answer is going to be log base 10 of 6 to the 1/3 power. And if you want, you can leave it like that. That's totally fine. You can rewrite. You can finish off with log base 10 of a cubic root of 6, and that's what the 1/3 power actually means. Okay, so you can write like this either way, and you can write parentheses around it either way. Okay. To me, right now, it looks a little too cluttery, like too much things going on. So I'm going to go ahead and leave the parentheses out. Okay, it looks a little nicer and cleaner that way. Whereas number 13, it looks a little cleaner if you put a parentheses there. So it's a matter of preference. Okay, so this one, I'm going to go ahead and look at it and realize that you have a some kind of a product multiplied into log base 10 of 3, and then you have another product of 4 multiplied into log base 10 of 8, which I'm going to use the product rule. Okay, so that's going to end up being log base 10 of 3 to the 4th power minus log base 10 of 8 to the 4th power. And since this is a subtraction, I'm going to go ahead and combine this into one log. So this will be a log base 10 of, and subtraction really means that it's going to be a quotient. So it's going to be 3 to the 4th power over 8 to the 4th power. You can even go one step further and factor not really factor, but it works the same way. Factor the 4 out of both of these, the 3 on top and the 8 on the denominator, and you'll finally get a log 3/8 to the 4th power. Okay, and again, we could have went a different route with this as well. Okay, we could have combined it first, but okay. 16. I'll start using red. Notice that these are all additions, or that means that we're going to have some multiplication or use the product rule. So we're going to have log 2 times 11 times 7. Okay, and you can put parentheses, make it look a little cleaner. Right? Now, you don't want to multiply 2 times 11 times 7, because whatever you get, 22 times 7, right? Right, 22 times 7, 14, 15. All right, so if you end up with log of 154, that's fine. But, I mean, I'm not really condensing it. And when I condense it, I kind of want to see where all the stuff came from. So, I mean, this is okay, log of 154, but I want it just to condense into a single log. And for me, this is good. Okay. 154, I mean, I could divide that by a variety of other factors. I could have, 54, this could have been, just make it simple, 22 times 7, right? So, I mean, it could be log of 22 times 7, which is just log of 22 plus log of 7, which, like that, and then which equals log 22 plus log of 7. So by doing that, I've actually changed the structure of this. Yes, it's still 2 times 11 times 7, but it's broken up into different formats. So I'm not really liking that. And I don't see that as actually being condensed. Yes, it is condensed as log of 154. Okay, it is condensed, but it doesn't show a history to me. That's how I see it. It doesn't show the history of how I got to my condensed form. And for me, this is good. Okay, this one right here, we have log 7, and then I'm going to go ahead and utilize the power rule. Bring this back. Oops, this one, sorry. Okay, so that means that I'm going to have now minus log of 12 squared. And again, I don't want to turn that 12 squared into a 144 because, again, that would lose the structure of that it was originally 12 and a 2 in the front. Because if I made it into 144, it could be a number of other things. Okay, so I'm going to kind of leave it like that, and then I'm going to go ahead and work out the subtraction. So this will be combined to a single log of 7 on top and 12 squared on the bottom, and that's all I'm going to leave it at. Okay, so this one is kind of the same as the first one that we did on this page, number 14. It's the same kind of idea. Okay, so I'm going to go ahead and rewrite this first as 2/3 times log of 7. Okay, you can see how that looks. And then now I'm going to go ahead and use the power rule, the backwards power rule, the inverse power rule. Okay, not really a thing, but the backwards of it. So if you have a coefficient in the front multiplying to a log, you can take that coefficient and bring it to the back of the argument and put it as an exponent. So final answer, log 7 to the 2/3 power. Okay, and if you want parentheses, you can. I just think it's going to be a little cluttery and a little messy that way. Okay, 19. We're going to bring the 6 to the back, the u, and bring the 6 to the back of the v. Actually, let's do this a little slightly different way. Okay, because they're both 6, just like how we did one of the other previous ones, when we have both 4s in the front. I believe that was, not this one, not on this side, but on the previous side. Right. So because they're both 6s, I can actually say, you know what? I'm going to go ahead and factor a 6 out of each of these terms. Right. So I'm going to factor a 6 out of each of those terms, which is going to leave me with 6 times log base 3. Ooh, this actually has base of u plus log base 3 of v. So that's what's going to happen if I factor a 6 out of both those terms. Okay, I'm going to erase that, make room. Okay. So with this, I'm going to go ahead and combine these because this is an addition. So I'm going to go ahead and use the product rule. So this is going to be 6 on the front, and on the inside, it's going to combine to be log base 3 of u times v. And I'm going to put parentheses around it, just going to keep it a little cleaner. And then now I'm going to use the backwards of the power rule and take this 6, and it's going to be multiplied into log base 3 of uv. So that power can actually be brought to the back of the argument. And that's going to equal log base 3 of u times v to the 6th power. Okay. And I'm going to just keep it there. Okay, because if you bring the 6 into the u and v, that's going to expand it just ever so slightly. So we don't want to go that. We don't want to go that way. Okay. All right. So these are log base e's or natural logs. So this is going to be, and I'm going to rewrite this because I do notice that there's a 4 in the front of the natural log or log base e, and that's going to be taken to the back of the y. So I'm going to write natural log or ln of x minus ln of y, and then that 4 in the front gets put in the back as an exponent. And then now noticing that this is a subtraction, I'm going to do a quotient rule in reverse. So this is going to end up being natural log of x over y to the 4th. Okay, and that's it. Okay, 21. So same scenario. Noticing that the 6 can be brought to the back of as an exponent for the v. So I'm going to have log base 4 of u minus log base 4 of v to the 6th power. Okay, and then noticing it's a subtraction, I'm going to go ahead and rewrite this as 1 log log base 4 of u on top, v to the 6th power on the bottom. Okay. And with number 21 or 20, it's okay either way. If you want to put parentheses, it's always okay, but this actually will look just as clean as if you didn't put it. So it doesn't matter either way. Okay, so 21 and 20. Okay, same thing. You're gonna bring this 5 and use a different color because it's a little tight. Use red. So this 5, notice in the front as a product or as a multiple of log base 3 of v. Bring it to the back. So we're gonna end up with log base 3 of u minus log base 3 of v to the 5th power. Okay, and then noticing this is a difference, I can rewrite this as a single log base 3 of u on top, v to the 5th power on the bottom. And again, parentheses is okay, at least for me, for number 22. Okay, a couple more. 23, noticing that this right here can be brought to the back of the u as an exponent, and the 5 can also be brought to the back of the v as an exponent. So I'm going to rewrite this as log base 6 of u to the 20th power plus log base 6 of v to the 5th power. Okay, and then noticing that this is a sum, I can rewrite this as a product with a single log base 6, and then I'm going to use parentheses, u to the 30th times v to the 5th power. Okay. Just thinking about it, 5 is a factor of 30 and 5. So if you want, and tell me what you guys think, right? You can write it in the comment. I've actually enabled comments. I stopped making these videos for kids. I know you guys are kids, but I stopped making it just for kids, and I made it so that way it's not for kids, and you can actually make a comment. But tell me what you guys think. Is this second method, or is this continuation more condensed, right? So I'm going to go ahead and do log base 6, and I'm going to factor, and again, it's not really factoring, but I'm going to take a, factor 5 out of 30 and the 5. So log base 6 of u to the 6th power times v, and then I'm going to put a 5 on the outside. Okay, so tell me what you think about this alternative answer to this original answer. Okay, is it more condensed? Maybe not. All right, but leave a message in the comment if you dare. Okay, I'm gonna go to green now, or actually I'll stick to blue. All right, notice the same thing again. 4, you can bring that back to into the back of the u, and 20 you can bring to the back of the v. Actually, let's think about it in a different way. Okay, so kind of like the last one, let's say, what, can we factor a 4 and a 20? Can we factor something out of 4 and 20? And the answer is yes, we can factor a 4 out. So if we go that route, we'll have a 4 in the front, and then we'll have log log base 3 of u minus, and if I factor 4 out of the 20, I'll be left with 5 times log base 3 of v. And then you might notice that this 5 in front of the log base 3v, I can bring that back as an exponent. So we will have 4 times log base 3 of u minus log base 3 of v, and this time the v gets the 5th power. And then now, notice that this is a subtraction. I can go ahead and rewrite this as 4 times log u on top, because it's going to now be a quotient, and v to the 5th power on the bottom. Okay. And then knowing that this is 4 times, so actually I'm going to do it like this. I'm going to go ahead and get rid of this parentheses. Right, and then I'm going to go ahead and say, I'm going to put a little or like a thin parentheses around that. And this tells me that I can take this 4, which is multiplied to the log. I'm going to bring it to the back of that argument as a power. So at the end of the day, I will end up with log. Oh, lost my base 3 somewhere right there. Log base 3 of u over v to the 5th power, and then to the 4th power. So in a sense, you can think about this. It kind of looks like the second way that I wrote it. Okay, but let me know. Right? Is this more condensed, or you know what? Am I mistaken here? And maybe I should condense it more to be log, so that it looks more like this one right here. Okay, maybe I should condense it more to be log base 3 of u to the 4th power v to the 20th power. Okay, and that was simply just taking this 4 and sort of distributing it into that argument right there. So leave me in the comment. See what you guys think. Okay. Okay, 25. Okay. Again, you can do this a number of ways, but I'm just going to go with whatever comes to mind. So I'm thinking, you know what? Let's go ahead and combine the logs on the inside because that is a subtraction. So I'm going to go ahead and combine that and write a quotient for that. So this is going to be 2 times log of 2x over y. Okay. Okay. And I'm going to go ahead and bring that times 2 as an exponent for that argument of 2x over y. So this will finally become log of 2x over y to the 2nd power. Okay, that's the first half of it. Okay, second half, I'm going to use red, which is back here. Okay, noticing back here that this is a addition, I'm going to go ahead and do a product. So this back in the back is going to be written as a log. Oops, you know what? Before we do that, let's take care of that little 2 in the front right there. That's a times 2, so I can bring it to the back of the 5 as a power of 5, power of 2, excuse me. So in the back, we'll have a log of 3 plus log of 5 power of 2. And I'm going to go ahead and combine those to be a log 3 times 5 squared. And I'm not going to change it to a 25 because, again, if I change it to 25, I lose the essence of what the 5 was, right? Because I don't know if it originally was 25. And luckily, 25 is an odd number, and not a lot of numbers are factors for 25. So so you either have that it used to be 5s or it used to be 25. But for example, if you had a number like 48, there is a lot of numbers that make 48. So you actually lose the essence of this log base 5 that we started out with. Okay. So I'm not going to go ahead and change that. So I'm going to leave it as 5 squared. Okay. So I changed it to, so I changed this to a single log and a single log. And then in between, you might have noticed that there is a subtraction in between. So that's a subtraction. And if it's a subtraction, I know that I'm going to have to use a quotient rule. So this one's going to go with, and I'm going to continue in green, write it as a single log. It'll be a log. And then this first part is going to be on top of a quotient. So 2x over y squared over, and then the second part is going to be on the bottom of that quotient. That'll be 3 times 5 squared. Okay, and I've rewritten this into a single log. I'll do this last one in purple, and it's a little tight squeeze. I could erase some stuff, but okay. So this one, if you think about it for a bit, okay, pause it if you don't want it ruined, but think about it for a bit, and you can think about it like this way. Okay, you can think about it as if log of x is going to be multiplied into the log of 2, which means if we're using the backwards of the quotient, the power rule, we can bring this that's being multiplied to the log to the back. So in a sense, we will have the answer of, sorry, let me kind of get rid of that. You will have the answer of log of 2 and then to the power of log of x. Okay? If you want, you can put parentheses right there. Or we'll put this in, we'll use orange. It's been a while. So we can actually rewrite this as, because it's if it's multiplication, we can rewrite it as log 2 times log x. That's pretty cool because now we can think of this as, hey, this log 2 is multiplied into the log, right, which means we can actually take the log 2 and put it as an exponent for the log x. So this right here can be rewritten as log x to the power of log 2. All right, so I thought that was pretty cool. So either way is fine, and if you want to use a parentheses, you can. All right, so either way is fine, but pretty cool. All right, guys, gals, that's a wrap for today.